Okay, another thing I want to review with you for your ACT is similar triangles and just some different ways that the questions can be asked that may seem confusing, but you actually know what you're doing, so just be careful when you're reading through them. Now, if we talk about similar triangles, remember similar triangles, the angles will have the same measure, but the sides are going to be proportional to each other. So this one is not really drawn to scale, but just be careful what they are asking for. For an example, they may say that the lengths of the sides of one triangle are 7, 9, and 14. And I really do not care how you draw your triangle. If this were an ACT type test question, I would just quickly draw a rough sketch. It doesn't have to be drawn to scale. Just label the parts. So if the side lengths of one triangle are 7, 9, and 14, and maybe they will just list the side values for you and not actually draw it. So the first thing you'll want to do is draw a triangle so you have a visual. They're going to ask you, what is the perimeter in inches of a similar triangle whose longest side is 7 inches? Well, I drew a similar triangle first, and then I read that the length is 7 inches, so I am showing that this is actually being enlarged. But if the longest side is 7 inches, it's actually a smaller triangle. And like I said, if this were the ACT test and it was timed, I would not worry about trying to fix anything. But it's going to be a smaller triangle where the longest side is 7. If I look at these corresponding sides, the longest side of both triangles, I see that what I am doing is I am just decreasing it by half. So every single side is going to be half. So this would be 9 halves, and this would be 7 halves. But I wouldn't even do that. I mean, if you had this and you type it in a calculator, is probably what I'm guessing some of you would do because you don't like fractions. But 9 halves plus 7 halves is 16 halves, which is 8, plus 7 means that your perimeter would be 15. But I wouldn't even do that. If the scale factor is a half, then the perimeter will also be a half. So if I look at it, I see that the scale factor is a half. Look at the perimeter. If you take 9 plus 7, you get 16, plus 14 is 30. Well, the scale factor is a half, so the perimeter of your figure, the one that you are looking for, this smaller triangle here, is going to be half the perimeter of the other triangle. It's going to just use that scale factor. So then you find out that it's 15. So I don't know what's easier for you, trying to take a half of each one of the sides and then add those together to find perimeter. To me, that may not be as fast as for others if you realize that, oh, I'm just taking half of it. So the scale factor is a half, the perimeter will be half of it. Now, if you were talking area, if it were a half, then it's going to be a fourth of it. Let's see, so perimeter would be the same as the scale factor. If you talk about a scale factor, the area is going to be equal to the scale factor squared. So if the scale factor was 1/2 and you square that, that means that it will be 1/4 as much as it was before. So the area would be 30 divided by 4. And that's what the area would be, or 15 halves, or 7.5. That's what the area would be when you have the longest side being 7. If the area was 30. But it's not, the perimeter is 30. So I hope this little bit right here did not throw you off. But for this one, all you got to realize is that's a half. So the perimeter will be a half. So if the perimeter of the original figure is 30, then the perimeter of the new figure will be 15. Okay, so for an example 2, what if I told you the lengths of the sides of one triangle are 3, 7, and 8 meters respectively? So I have this triangle here. I don't care how you draw your triangle. I just know it's going to be scalene, but the lengths of the sides are 3, 7, and 8 respectively. If the perimeter of a similar triangle, so now I have this similar triangle over here, if the perimeter is 27, what is the length of the longest side of that particular triangle? Well, if I look at this small triangle, I see that the perimeter is equal to 18. And just like I mentioned in the previous problem where you have that scale factor, the same thing happens with the sides. So if this side was half, then the perimeter is also half. Let's see what the scale factor is for this. So the scale factor can go actually in two different ways. If I am going from the small one to the largest one, it says I take 18 times what value to get 27. That's a scale factor. If this happened to be 36, I would just be doubling it, and I would say that that scale factor is 2, or mentally everybody goes, oh, just double each side. But I can't see what I take 7 times to get a value over here because it's unknown. I can't see what do I take 8 times to get this value here. There are no side lengths of this triangle. I just know the perimeter is 27. So if I find that scale factor, we divide by 18 on both sides, and I find out that x, or my scale factor, if I reduce this, is going to be 3/2. So I am increasing it. If you were to go to a copy machine and copy off a triangle, 100% means it's going to be exactly the same. If I change it to 150%, it's going to increase it to, it would be 1.5 times the original size. If I put it at 200%, it's going to be 2 times as big as it was before. So this is 3/2. That's going to be that scale factor. So to find out what is the longest side, it is, if I knew another side, you guys would set up a proportion, but since I don't, I just take a side times the scale factor. So I'm going to take 8 times 3/2. And if you calculate that, you are going to get a value of 12. So this side length right here would be 12. Now keep in mind the scale factor going the other way. I don't take 12 times 3/2 to get 8. So what you need to keep in mind is the scale factor going in the opposite direction will be the reciprocal of this value. So the scale factor going in the opposite direction would be 2/3. Very seldom would you use that, but just keep that in mind, which direction you are going. Is it going to get larger or is it going to get smaller? If you were to take 12 times 2/3, you get 8, which is this corresponding value right here. And in Saxon, we never did, in Algebra 2 last year, we did not use scale factor very much. We usually just set up a proportion. But here, I want to show you how to look at that scale factor. Okay, another example of how you might use scale factors. If I gave you the following figure, and I said that P lies on BQ. So I see that P lies on BQ, and A lies on CQ. I see that. If I tell you that AP is parallel to BC, the only reason they give you that information is Q is the same in 2 separate triangles. You're going to see this smaller triangle here that is APQ, and then you're going to see this larger triangle here that is going to be CBQ. And in those 2 triangles, I know that Q is the same angle. When these lines are parallel, these corresponding angles become equal, so I know that P is the same thing as B, but I also know that A is the same thing as C, because if 2 angles of one triangle equal 2 angles of another triangle, then the third angles are equal, or because these lines are parallel, those are corresponding angles. So we know, that's the only reason that they sit there and give you all of that information. They're going to tell you that AP is going to be 7 units long. So if I told you AP was 7 units long, sometimes it's easier to look at it as the 2 separate triangles instead of the overall figure. They're also going to tell you that PQ has a length of 9. So I know that this distance here is 9. Then they're going to say BC will be 14 units long. So I can go ahead and mark that over here in these separate triangles if you want. And what you've noticed is you have actually had a scale factor. You're doubling that triangle. If I look at it, you're going to say 7, what do I multiply it by to get 14? Just like we were talking about in the last example as far as finding that scale factor. So we are doubling it as we go from APQ to CBQ. So that says that this distance here is going to be 18 because it's double. Now what the question is going to ask you though is they are going to ask you how long is BP. So this is what they are looking for, is this distance right here. So I don't want that full distance of 18, and I can almost guarantee you that in a multiple choice question 18 is going to be one of the answers. But all they want to know is this distance right here of BP. So if QP is 9, the full distance is 18, that means that PB would have a length of 9. So please read those questions carefully, because otherwise you're going to, 18 is going to be that answer, and it's going to be a hook, line, sinker, and they're going to get you with answering the wrong question. So read through them carefully. Okay, another thing that they may give you, and I marked this as a right triangle, and I probably should not have. I just know that it's going to be a right triangle because of the information. If they told you, once again, that these lines are going to be parallel to each other, so we know that these are similar triangles because Q is in both, and P and B are equal because they are corresponding angles. A and C are congruent. I shouldn't say that. I should say QAP is congruent to QCB because those are corresponding angles. So as we look at this, if they told you that PQ, so PQ is 20, once again, probably what I would do is go ahead and draw these triangles separately. And if you just draw them in corresponding parts, you probably do not have to label them again if you are confident in your recognition of side parts. But they tell you that PQ is 8 units long, BQ is 20 units long, and AP is 6 units long. They want to know how long is BC. All right, some of you just have this down from algebra, that if you are looking for that side right there, what you would do is you would set up a proportion. 8 over 6 is equal to 20 over x, and you would type in your calculator, cross multiply, and divide. Others of you, if you were to look at this triangle right here, and the reason that I accidentally marked this as a right angle right there, is this triangle right here is what is referred to as, if we look at it, it is a 3, 4, 5 triangle. It's a special triangle. So it's a 3, 4, 5 triangle, and the scale factor to this one would be 2. So even I know that this would be 10 right there. But if I look over here, I see what I have done is I have increased it by a scale factor of 5. So that means that x would be equal to 3 times 5, which is 15. Now, be awfully careful of that type of problem. Like I said, if you're going to solve here, go ahead and take your calculator, 20 times 6 and divide by 8. For some of you, that's going to be faster. But never forget that you do have that 3, 4, 5 triangle. And there's another special right triangle, and I will get to that in the next video. This video is about to end. I think there was just a couple more examples that I was going to do with you. So be ready for another video. It will be a lot shorter. This one is 15 minutes, but the next one will be shorter, and then I'll create one on similar triangles.